Hello, I'm Jun Clemente, and I'm thrilled to share with you the insights we've gained through our analysis of the Kings County, Washington housing dataset. Today, with my colleagues Tanya Ortega and Sasha Libolt, we'll explore the factors influencing housing prices in this region. Let's dive in. Our goal is to develop a multilinear regression model to predict housing prices in King County using Python. This model will help us understand the relationships between various housing characteristics and their impact on price. To get there, we'll follow a four-step approach. 1. Data preprocessing, where we clean and organize the raw data for analysis. 2. Data analysis, where we explore trends, patterns, and relationships within the data. 3. Data modeling, where we build and evaluate multilinear regression models. And finally, 4. Machine learning testing, where we validate our model's performance. Real-world data often requires cleaning before analysis. Our dataset, containing information on over 21,000 housing sales from May 2014 to May 2015, was no exception. Missing values were addressed using mode and median imputation. Errors were identified and addressed, including resolving typographical errors like number of bedrooms and inconsistencies within the view variable. Outliers were removed to normalize the dataset. Additionally, we employed linear regression to create zip code groups. This technique allows us to better account for location when analyzing prices. By applying these pre-processing steps, we were able to refine our dataset to a more focused version with 16,850 rows and 19 columns. Additionally, we applied data transformations in order to make the data more efficient, resulting in a reduced size of 1.8 megabytes from 4.8 megabytes. As reviewed in the previous slide, we removed all outliers in order to normalize our dataset. Some examples of this are removing high outliers for price, safeguarding against skewed pricing data. Additionally, we removed bedrooms and bathrooms that had a value of 0 for better data consistency.
Hello, I'm Tanya. Now that we have a clean and pre-processed data set, it's time to dig deeper and explore some key trends within the King County housing market. This initial analysis will provide valuable insights that will inform the development of our multilinear regression model. The KDE plot illustrates house pricing distribution in King County by zip code groups, with a positively skewed distribution. Most prices are above the mean of 448,760. Even after removing an outlier, there's still significant pricing with the standard deviation of 191,679. Next, we have average price by zip group and grade. This examines the relationship between price and property grade. We can see a clear trend. Houses with higher grades tend to be more expensive across all the zip groups. Interesting, zip group 4 has both the highest concentration of expensive houses and properties with higher grades, 5 or above. But zip group 0 has the lowest average prices and tends towards lower grade housing. Now we have a bar graph that visualizes the relationship between number of bathrooms and housing price. As expected, we see a positive correlation. Houses with more bathrooms generally command a higher price. This scatter plot shows that square footage is positively correlated with pricing. Generally, houses with large living areas tend to be more expensive. However, the spread of data points around the trend line suggests that square footage isn't the sole factor influencing the price. As we discussed earlier, price distribution is positively skewed, as you can see in the top left. Square foot living is more evenly distributed with a somewhat bell-shaped curve. However, there is a large concentration of housing at around 2,000 square feet. This heat map effectively visualizes the relationships between the features of our data. We can see strong correlations between the zip code group, property grade, square footage, and the number of bathrooms. This suggests that these features are likely interdependent and influence housing prices together. Now let's see how these highly correlated features interact. This visualization technique, called a pair plot, provides a detailed view for each feature colored by zip group. Diagonally, we see the distribution of each feature with histograms and density curves. For example, this top left corner plot shows the distribution of price by zip group. The more interesting insights come from the scatter plots, where we can see the features related to each other. For example, you have a positive relationship that is nearly identical, indicated with grade and price, as well as grade and square foot living.
Hello, I'm Sasha Libolt. Now that we've unveiled key trends and relationships within the data, let's leverage this knowledge to make predictions. This is where data modeling comes in. In the following slides, we'll examine some multilinear regression models and test their effectiveness using machine learning techniques. We began with the hypothesis that housing prices can be effectively predicted using multilinear regression. Our initial model incorporated predictors with a correlation of approximately 0.4 or more from our prior analysis. Zip group, grade, square footage living, and bathrooms. However, to ensure the model's accuracy, we performed a variance inflation factor test, or VIF. This analysis helps us identify redundant features that might distort the model. Based on this analysis, we removed the grade due to its high multicollinearity with other features. This refinement led to Model 2, consisting of zip code group, square footage, and number of bathrooms. While VIF analysis proved multicollinearity was no longer a concern, we noticed the bathrooms feature had a high standard of error and low t-score. This suggests that it might not be statistically significant in explaining price variations. Therefore, we removed bathrooms as well. This led to our final model, Model 3, which focuses on zip code group and square footage as the key factors influencing King County housing prices. The accompanying graph visualizes the relationship between all features and price, along with the model's predicted fit. Here we display the output of all three models from OLS regression. While Model 1 does look like it may be the strongest, multicollinearity with grade is a concern. Model 2 and Model 3, which address multicollinearity, yielded very similar results. To ensure the reliability of our predictions, we put all three models to the test using machine learning techniques. We employed libraries like scikit-learn and stats models to train and test each model. The data was divided into an 80-20 split for training and evaluation. The results from both libraries were consistent. We further validated the models using k-fold cross-validation. Dividing the data into 5 sets, each model underwent training and evaluation 5 times using distinct folds. The R-squared value was computed for each iteration, and the average was derived, providing a comprehensive understanding of model performance. Our machine learning tests confirmed the model results. While Model 1 might have shown promise initially, the multicollinearity with grade posed a risk. Model 3 emerged as the optimal choice due to statistical analysis and machine learning validation. This model focuses on zip code group and square footage as the key factors influencing King County housing prices. Looking ahead, we suggest expanding the research scope by incorporating additional data sets from various regions within Washington state. Additionally, exploring comparable counties in other states could provide valuable insights. By enlarging the dataset, future analysis can achieve a more comprehensive understanding of housing sales dynamics, thereby enhancing the quality and depth of research findings.